right, let's move this thing over here. I don't know why they did that. All right, here we go. First of all, this word, what is it? Okay, we're going to call it that's how you should pronounce it. Say it. Arithmetic. Can I do like an accent over the whole thing? Arithmetic. Okay. Arithmetic. Arithmetic. Because it's an adjective. It's not a noun like arithmetic. Okay. Anyway, what's the next term of the arithmetic sequence? Tell me what's the pattern. What's happening? Is it actually going up by 5 though? Aha. Right. So what would the next number be? Here we go. This one. Okay. So easy peasy, right? That's the first one. An arithmetic sequence means you're going to add or subtract the same number over and over and over again. In this case, the constant difference is something you're going to need to know. The difference is 3. Okay. This one, what's the constant difference? D. The constant difference is 5. Next number, 17. What if it is going down? What would the constant difference be? Positive or negative? Negative, right? We don't have one of those, so I'm skipping it. Anyway, now, what if you're given a formula? How can you figure out, using this formula right here, what the 5th term is? Any ideas what to do with the number 5? Yeah, you're right. N is the number in the sequence. All right, so sequences are like functions. You can plug in numbers and it'll spit out that term in the sequence. So if I want to figure out what's the 5th term, I'm going to plug in 5. Just like that. Now, this sort of setup here, what should I do first? Yes, thank you. You have to do the parentheses first, right? Whatever's in parentheses must be done first. So that's 4. And then so now it says 4 times 4. You would be surprised how many people do this part first. What should you do next? Right, so now it's actually 6 minus 16, which is negative 10. Okay, sweet. Let's do another one of those. All of these look the same way. We have 2 versions, this one and the last one, and no other kinds. All right, so this is called a certain kind of formula. This is called recursive. All right, so real quick, let's look at that word, recursive. Well, I don't want formula. I just want recursive. See this? These pictures? Yeah. What do you notice in the picture? Triangle. And then? Triangle. And then off of that triangle, more triangles, right? This is a picture of a tree seemingly, but actually it's recursion. It is the same pattern over and over and over again. Right? A branch, and then off that branch are branches that have the same pattern, which have the same pattern, which have the same pattern. Right? That's called recursion. So recursion means you start with something and then you do the next thing. Like you start with one mirror and then you put it in front of a mirror and then you see the image of the image of the image of the image of the image, right? You ever see that sort of thing? Okay. All right. That's recursion. All right. So a recursive formula in math means you start with a number and you do the same thing over and over again. So what are we going to do? What's the clue that I just circled? What are we going to do? Yeah, we're going to subtract 7 over and over and over again. What does it say to do? Find the third term. So this is the first term. That's what this means right here. This is the second term because they told us to do what every time? Subtract 7. So this looks very confusing, but that's all it means. Here's the first number in the list. This is what you do every time. All right, so this is your third number, which is the one we wanted.
Wouldn't it be -5?
What?
It starts with -2 and goes down to -7.
No, you subtract 7 every time. -2 minus 7 is -9. Okay. Okay. So building on that, you're going to create the recursive formula. What's the first number? That's what that spot means. This means, what are you adding each time? This could be negative. Yeah, you're actually subtracting 20, right? So you're adding a -20 each time. Again, recursion, the same thing over and over again. Here, what's my first term? What are you adding each time? 4. Whoa. Okay, that's easy enough, right? Last one for today. You're going to want to write this one down, okay? Here's your formula. Every time, you need to first of all figure out these two things. What's the first term? A1. When I say A1, I mean the first term. So that's 170. All right, sweet. And then D. I talked about it earlier. What's D? D is the common difference. So what's happening? Yes, it's subtracting 85. So we have to say -85. Now, you're going to use these two numbers in the following formula. The formula looks like this. And the reason we set it up this way is because, think through this with me. You start with the first number in the list, and you add a certain number so many times, except for the first time. On the first number, you don't add anything to it to get the first number. It just is the first number, right? So if we just said D times N and we plugged in 1, that wouldn't make any sense then anymore. So we take 1 away, and then we multiply by D. Now, our formula would look like this on this particular question. Since it's -85, I'm just going to say minus. And I'm going to write it like that. And that's all. Now, if you wanted to, you could distribute the 85 to the n and to the -1 and come up with a new formula. You could do that. That formula would look like this. -85n plus 85. And then you could combine these two numbers, and it would say 255 minus 85n. So that's another formula you could use if you wanted to go through all that work. But I bet you don't want to do that. All right. Questions on that one? Let's keep going. Now, we are given two different people's versions of a formula, just like I showed you. There could be two different formulas, right? There could be. So let's double check. Let's see if Gustavo's right. Let's see if Yuki's right, or maybe they're both right. Both. Here's how you can check somebody's, or let's just do this. Let's actually form the formula ourselves. We should start with A1. A1 is 19, right? What's the common difference? What's happening? Good, minus 19, so this is kind of confusing. But the formula that we would write would look like this. That's what we would write. Now, I don't see that up there, but it doesn't mean they're both wrong. What can we do with the minus 19? Yeah, let's distribute that. Negative 19 times negative 1. Positive 19. So we should have 38 minus 19n. This one or that one should be there. Is it? No. You could even check it this way. You could say, hey, let's plug in a number and check to see if it fits the formula. For example, 1, that's for the first term, that's the second term, and that's the third term. That's the fourth term. If I wanted to plug in 3, oh my, whoa. If I plug in 3 into this one right here, negative 19 better pop out of it, okay? So 19 minus 19 times 3. And you can pick any number in the list. I just picked 3. 19 times 3, what's that, people? 57, awesome. 19 minus 57, is that negative 19? Ooh, let's check it, right? No, it's not. 19 minus 57. So that's wrong. I did the same thing here and I plugged in 3 right here. I'm not going to get negative 19 either. Okay, so you can work it out the way in which you identify the two possible formulas, or you could plug it in and check to confirm. Deal? So, which one of these is it? Yeah. That's all for today. Congratulations.